Hello, all my YouTube viewers and subscribers. Welcome to another video from Ellensburg Amplifier Repair and Service. Today, as you can see here, we have a Drago by Massive Audio, a DP24K amplifier that I have been working on for a little while now. I've been doing this amplifier, of course, with no schematic. This is the first DP24K I've had in. And this video is mainly for the repair techs out there that want to find little different avenues of testing things. And this is a prime example of a way to test something without dealing with the crazy high voltages that these things will produce. So just as a general idea of the kind of voltages that you're dealing with on a DP24 is the rail capacitors are rated to 400 volts. And if anyone's been doing this for a while, you kind of start to learn and understand that you're about anywhere from 20 to maybe at the max 40 volts from peak voltage of the rail capacitors. So when I see a 400 volt rail capacitor, I'm going to safely assume you're 340 to 370 volts. That's potential across these transistors. So I wanted to be able to test the output section without having to deal with the almost 400 volts potential. For safety reasons, of course. So what I usually always tell my people that ask the questions when it comes to diagnosing and testing amplifiers is to divide the amplifiers up. Work on the power supply, work on the output section, divide the amp in half. Usually most amps will start if you pull the output transistors. There's many ways to go about it. In the lower voltage amplifiers, I really don't mind just firing up the board and testing the output. But on boards like this, I would much rather deal with 15 volts versus 400 volts when I'm dealing with a problem. And there is a problem with this board. I've got it pretty much done. The power supply here had to be rebuilt head to toe. The full power supply had to be rebuilt. The output section of this bank here, this section was shorted. It was missing diodes, missing drivers. Someone had already been in this amplifier and diagnosed this. I'm just kind of picking up where someone else left off. The inductors are beyond, like, I would not even consider them remotely adequate, so I did end up gluing these down last week. But I'm at a fault in the auxiliary power supply. When I first originally brought this to the test bench, because I had all my measurements were spot on, so I felt good, fired it up. Well, I lost the rectifiers over here, the discrete rectifiers. Discrete diodes, I'm sorry. It's set up as a bridge rectifier. So that burned up, which tells me I have a short in either the plus minus 15 volts for the preamp or the 15 volts that supplies power to the drive ICs. So I went a couple ways about doing this. I decided I am going to test this amplifier without 400 volts, which you can completely do. You do have to have an input signal. Here, as you can see, what are these? These are the, oh gosh, this is a NOR gate flip-flop. What is this? This is the 14011B. I think it's a CMOS flip-flop. I'd have to look at the data sheet. Kind of a common setup that they'll do is they'll take a signal, they'll use a flip-flop and make that your positive and negative square signal reference to a different voltage. And that's what they're doing here, is they're kind of separating the drive from the actual preamp voltage. They have their own voltage supplying those, which when I repaired the rectifier section, I lost an IC over here, which was the original IC, which I kind of thought for a second there that, yeah, it could be damaged because this drive IC was actually missing. Sorry, the scope image is kind of covering that IC up right here, but it is right here. This was not installed when I got the amp, which I should have told myself, you know, hey, we might want to replace the flip-flop that's above it if you had a shorted drive IC, because obviously they could go back and short that out. So I replaced it with a new flip-flop IC straight from Mauser. Fired up the auxiliary power supply, and the other one popped. I'm like, what is going on? So I'm not quite sure if this was also damaged when this one failed, which is very possible because they share the same circuitry per se. So this is just another method of me powering up an auxiliary power supply, besides using my plus minus power supplies. I'm just using a standard amplifier power supply to drive this, which works perfect. I'm just substituting the windings from this transformer with a separate power supply. It's doing the exact same thing that this transformer is doing though, which is allowing us to not have to worry about building rail voltage. Just make sure you disconnect your wires, otherwise your square wave will go back through this transformer, and then you're going to start switching things, especially the rectifiers. So disconnect your transformer if you can. Most auxiliary taps are really accessible. You can just pop them right out of that board. So let's go ahead and fire up this amplifier, my power supply amplifier. And a little click. It's still an active amplifier. The relay clicks in and everything. I'm just tapping off the AC side of the rectifiers. So let's see here. And you guys have the scope right here, right in the upper corner here. So we're gonna see here our plus 15 volts, and then we're gonna see our plus 15 volts for the preamp and our negative 15 volts for the preamp. So everything seems good to go. The preamp works. I don't get any excessive heat on the rectifiers. I have the plus 15 volts, which I do believe was pin 14, right? Yes, pin 14 of the I call it flip-flop. I have to double check the data sheet, guys. But I do believe it is a flip-flop, a CMOS flip-flop. So we do have our positive 15 volts for the power of those flip-flops, and the pin 7 is your ground, which we see no obvious issues with our ground. So the preamp itself, is it fired up? Let's check and see. We have plus SQ and negative SQ. All right, so there it is. We do have a square wave. I have a 50 hertz input signal going in. You have to kind of oscillate this thing yourself. I haven't gotten far enough into this to know if the PIC supplies a signal to keep the drives oscillating or not. But we do have our square wave going into pin 1, 2, pin 1 and 2 of the flip-flop. It does look like it has the initial input signal, which is good. All right, so pin 1 and 2 has our initial square wave. Pin 1 and pin 2. And we just want to make sure that no other pins have any values, any voltages that are what I would consider abnormal. And that is our positive 15 volts. So we do have our square wave going in. So let me put on 2 new flip-flops here. I'm wondering if I should change this drive IC. I will check the resistance. .17 mega ohms. 1.17 mega ohms. Let's see what the resistance is between the input pins. So there we go. 0.4 mega ohms. So we're going to be what, 400K. So that tells me we have an issue. Oh no, 500, never mind. So we're obviously dealing with some capacitance in the drive ICs. All right. So I think 400K, and this one here is 400. We're about 700K on that IC. So, and this one's 350. So we're gonna probably go ahead and I think I'm gonna go ahead and pull that IC, and just in case, I'm gonna go ahead and replace it. We didn't have any failed outputs on this side, but I think it's gonna be better safe than sorry to go ahead and replace that. I'm just gonna pull it off right now, just in case. What I'll do is I'll put a new flip-flop on, and I will fire up the preamp again, and make sure that our flip-flops don't short out again. I initially have not really realized what the initial short was that took out the rectifier, or the discrete diodes. It had to have been a pretty substantial current. And I think these flip-flops would have burned up before burning up the diodes. So I'm not quite sure. I'm still tracking down this secondary, or not secondary, the preamp short. So I will, I'll get these 2 flip-flops soldered back on here, and I will be right back with you. All right, guys, I am back with you. These are CMOS, just standard CMOS logic gates, ICs, just to let you know. While I finished up soldering these new ones on, I went and checked the data sheet for you guys, because I want to make sure I get the right information to you, and at least the right information to myself. So I'm just going to clean up my flux here. my good old Amtech Flux. Oh, and you guys can always find my Amazon affiliate links down below to the equipment supplies that I most commonly use, if you so choose to check them out. The Amtech Flux works great. It can be a little thin. I'm thinking about probably going with a little heavier flux, especially when you use hot air. This flux here, the NC 559, it'll pool out pretty wide when you hit it with the hot air. So I have never really tried any other thicker, I should say, flux. So I may try that in the future. But just cleaning up the flux here with the good old trusty Q-tip. Now, I have the two CMOS gates installed. I have one drive IC installed. So I'm wondering, do we try and see, or do we pull this IC here just to make sure I don't have any shorts? It shouldn't matter, because the drive IC is on the output of the gates. So I don't know if the shorting of these CMOS gates have anything to do with the drive IC. I don't suspect they do. But there's two new ICs. This is a new drive IC. I don't see any shorts. Let me just double check with my good old UT 61E meter here from Unity. And make sure, I just want to make sure I don't have any shorts across the power, which power was 7 and 14. Let's make sure I don't have a short. 2.5 megs, I don't there, and then 7 and 14 here. 7.1K. Oh no, oh my goodness. My probes here are moving all around. 2.6 megs, 2.2 megs, 2.1 megs, and then it drops to 22K. Okay, that's interesting. Let's check this over here and see what this side is doing. I did. Let's just go to ground and positive. Oh, same over here. So we're 7.1K between the plus 15 volts and ground. So it's going to have to dissipate a pretty decent amount. So, which I could probably see why they use such big diodes then. All right, let's see here. Let's just see what it does. Turn it on. Usually, when I turn the power supply on, if there's a short somewhere, these little ICs will pop a little hole right in the middle of it. Let's hope it doesn't. I mean, they're cheap ICs. You can get them for under $1 through Mauser. But man, I hate having to continually replace ICs. And I just have no known reason why these are doing what they're doing, unless there's a Zener. No, I see it looks like a 4148 diode. Let's see here. Which is connected to ground, but is not related to the auxiliary power. 4.5K, it kind of is. Let's see here. Yeah, 4.7K. All right. Well, let's fire it up, see what it does. Oh, well, look at that. So no popped ICs. That's a good thing. All right, let's see. Do we still have an input signal? We do. Do we still have my square wave? I do still have my square wave. All right, so I should have drive. I do. All right, drive to the output IC. So now I know why this IC failed is because this drive IC has to have a short in it. Do I have a square wave to the other drive IC? I do have a square wave. All right. But of course, we're not going to see anything on the output of this IC because we don't have any voltage going on anywhere. So this just verifies the signal out to your drive IC, which these are the oddballs. You can still get them on Mauser, guys. The IR 25607S. These are the IR 25607S drivers, which I think they are pin-to-pin compatible with the 2013 or the 2113. The 2113 drive IC. But I don't know these amps good enough yet to know if I can just go ahead and use the 2113s versus having to find and purchase these oddball numbers here, the 25607S. So that tells me that I probably should replace this drive IC, which I do have another one. And then from there, I should be good to fire up the rails. So that's just what I wanted to go over with for you guys on this video today. Is you can use an auxiliary power supply, because that's all this is in the transformer. This is just an auxiliary power supply that's driven off the same drive as the power supply. So you can get an auxiliary power supply. Let me see if I can show you guys. So that's how I'm set up. My wires are just coming off of the rectifiers over here using the square wave that's built off the power supply, coming over, feeding the preamp section of this amplifier, going through the discrete diodes here, which is building a bridge rectifier for the voltage regulators. So I'm just substituting this transformer. And that allowed me to check the signal, input signal, 50 hertz, 50 hertz in, 50 hertz coming out. So that's telling me the preamp is functional. Do we get any oscillation without rail voltage? That's just the one last thing I want to check here. No, not really. I wouldn't think so because the amplifier's not active, but it's active enough for me to see the square wave. And nothing else is failing here, so I don't suspect any further issues for this amplifier. Unless, of course, I have an issue. These are new transistors, so there shouldn't be any problems. I think this thing will fire right up. So I do thank you guys for watching. If you have any questions about how this is done, how this is set up, and if you have questions about proper safety procedures dealing with electricity, please feel free to ask me questions. I am a more or less retired industrial electrician, so safety has always been part of my life. So thanks for watching, guys. And if you happen to fire this up with full rail voltage, please keep your fingers away from the rail section, the rectifiers, and the output transistors. They will have this voltage present, and this could really give you a bad day. So Thank you guys for watching, and if you like this kind of stuff, please like and subscribe. Leave your questions down below, and I'll get to you as soon as I can. Thanks for watching. Catch you on the next video. Thanks, guys.